To help with, there we go. So to help with, look who it is. That would have been a good shirt last week. Or, no, not this week. To help with your potential, now this is not counted as tutoring. If you go and do this on your own, it's not tutoring. Tutoring means sitting with someone and getting help. So I posted a review video already. So again, that's more of the basic circles stuff. It goes fast, but it's recorded, so you can stop, go back. It may not be enough if you really, really aren't getting it, and you need to go back and watch the full lesson. But if you just kind of need a reminder, probably best for people that got a passing grade on the quiz and just want to try to do better. I posted that and I go through some problems, some concepts, a little bit of everything. And it's what, 37 minutes. So again, obviously I can't cover everything we've done on circles in 37 minutes. So that's the basic stuff. Senioritis. Checked out, aren't you? Flags over.
Everything's open.
And then just for those of you that are news or chance, London business. Not that this making a good Calvin, but so if you go to YouTube, if you search Mr. Gill Geometry, that's how you get, and then you'll see a picture of this guy right here. Can't see it. That's a picture of a dog's face. Yeah, there we go. So you'll see, like, when you get the list of drop down stuff, you'll see that picture, that icon. That's my page. You go to my page and it lists all of the different classes that I've recorded. So if you're absent, I expect you to keep caught up. Like, there's no excuse for being absent because I record everything. I mean, really, there's no excuse anyway. Even if I didn't do that, you're still supposed to stay caught up. Any questions on any of that stuff before we start the lesson? All right. So I did not finish this in the other lesson. Page out, bro. I didn't finish that in the other lesson, so I didn't put it on the quiz. It was supposed to be, but really, this is the only class we didn't get to. Every other class got to it. But since we didn't get to it in this class, I didn't put it on the last quiz. It'll be on the next quiz. It's actually from, what was the lesson? 10 arcs and chords. I don't remember if it was arcs and chords, which was 10-3, I think, or if we got 10-4, but it's the last. You'll see that exact image. It's right before the next thing, like it's on the same page for the next thing I'm going to show you as well. If I tell you, so this is a little bit of a review also, for those of you that need to do the retake on the tangent lines. If I tell you a line is tangent to the circle, there's one number one concept that you got to know. This is really the only concept that would be a difficult thing to remember, because the other one you're going to guess correctly. What is that concept? I tell you, RQ is tangent to circle P. What do you need to know? When I say one thing, I expect you to know one thing. Chance. Well, it's not really a triangle. Wrong, correct train of thought, but it's not always a triangle. There is a right angle. So if we draw a triangle, then yes. That's my point. They're not going to draw it in for you. They're going to simply tell you that. So again, this is the difference between you've done geometry at pretty much every math class you've ever been in. 7th grade, you did a ton of geometry. Then in pre-algebra, not as much, but there was one section, mainly right triangles. In the high school level of geometry, they don't walk you through every step you need to do. You got to figure it out. All they're going to tell you is a line is tangent. You then have to know, well, let's do black. if this line, so again, QR is the one I'm doing right now, if it is tangent to the circle, that means it is perpendicular to the radius. So perpendicular means 90 degrees. You have to make that connection. So it also told us TR's tangent, which means that is also 90 degrees. Now, this is its own theorem, but if you just understand what I just said, that tangent lines are perpendicular, you don't need to memorize this theorem. The theorem says if you have two tangent lines that are drawn out of the same point, or that originate, or however it words it. Yeah, we're still in the loop. So if you have two tangent lines to a circle from an exterior point, the theorem says this angle plus this angle, I guess we can just use one letter in these because there's no other angles there, have to equal 180. That's what the theorem said. You can memorize it. You can look for a shape like that. You can memorize it. So it's a central angle. I think it says the central angle and the exterior. Oh, no. Actually, I think it says something about inscribed angle. It's a picture like that, though. I would call it the exterior angle, but they call it like I don't know how they call it inscribed. It would be this one down here. So I don't remember. You didn't look. I'm gonna just again go over the concept. If you just understand, so again, you can memorize that. Those two angles always add up to 180. But if you just understand, we're dealing with two tangent lines. We have two 90-degree angles. Going way back, which is actually what we're going to use in the next problem, how many degrees in any four-sided figure? 360, right? Because I can make two triangles. So we'll kind of start in the next one. If I have any four-sided, actually, let's use this straighter line. If I have any four-sided figure, I can draw a line from one corner to the opposite corner. I can create two triangles, and we know all triangles add up to 180. So 180 plus 180 is 360. So we did that a long time ago. This was EOC review. So if I know that's a four-sided figure, which it is, I know there's a total of 360. I know I got 90 degrees here and 90 degrees here because they're tangent, and the other two angles have to be 180. So there's a way to understand concepts and not have to memorize this, which will, I think, stick longer. Or want to study right before the quiz, right before the quiz, which we didn't really do on the last quiz. You can also get away with that from my quiz. I don't know if that'll stick for the EOC. Let's see. That's really the only two things, that these are 90-degree angles, which means those two have to add up to 180. Those were the two things in that. And the next one, now that I've covered kind of the big concept, the fact that that is a four-sided figure, quadrilateral. We just said there's 360 degrees in all four-sided figures. If you did not set that up, try to set it up now. Paper. Exactly. That's my point. We need to get on there and then start saying, hey, you need to know, like, when we're doing it, we got all this thing, because they're not jumping on it. I'm not jumping on it.
I picked related to game. I don't do this.
Yeah. I mean, it's early. Although, yeah, hours would take learn. I'll give you a minute to try to solve that, set the equation up. At the very least, you hopefully can set the equation up for that too. Tammy does. Nobody else. She went. Oh, gotcha. Well, she could just do it for fun. Sometimes when you like sports, you just do them for fun. Well, neither of them do. All right, so again, kind of a quick review, but this actually applies to future stuff as well. What is important to note about that figure? First thing that you should notice. Say it again. Okay. Drew the line in, so you would have had that. So yeah. What should you notice immediately about that figure? We have four sides. Like taking it a step, like something that isn't quite as obvious, but that we've talked about many times. Did I tell you to look for? Will distinguish between what you're measuring. Degree symbol. You have degree symbols in all of those expressions. What's about what? Angles. So again, that's going to trigger a lot of stuff. Or if it's, more importantly, if it's not there, it should eliminate stuff. I still have people trying to add things up to 180 or 360 or 90 when it's not even about the measure of angle, about the length of stuff. Lengths do not add up to those numbers. Angles can. So if you see that degree symbol, then yeah, you might use some of those numbers. You might use 90, 180, 360 or higher. But if that degree symbol is not there, those numbers go away. There's nothing, can't be anything about those numbers. Length don't add up to those numbers. So in this case, we've already kind of gone over it. I split that into two triangles. All four-sided figures are 360. So that is the measure of an angle. Everything before the degree symbol. Doesn't matter what it looks like. If it wasn't about an angle, it would still be a measure. It would just be a length. Everything in this just combined will create one number once we hopefully know what X is. So these are the measures. So if I know all four angles add up to 360, that's my equation. 3x plus 32. So that's one angle plus 6x. Subtract 20. There's another one. Plus 4x. Whoop. Subtract 12. 12 plus 3x plus 14 equals 3. That's your equation. From there, it's just algebra. So you combine all the x terms. What do we get? In 16x, it looks like. So x's, 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 x's. Oh, shoot. We can't do that yet. So now we combine all the numbers. So that's positive 12. Oh, 0. Didn't mean that to happen. Plus 14 equals 360. So I just combine all the numbers to get the 14, just like combine all the x's. Now that's a two-step equation. Whoops, that's good. Subtract 14, subtract 14. 346. And what's the last step? But what do you get when you divide by 16? So you divide both of those by 16. Nobody did it? 20.5. I know. I mean, I do have one. Actually, oh yeah, I do. What's 34 or 346 divided by 16? Sure. You got 21. Just somebody do it. 346 divided by 16. Say it again. Again, you can round that off. Oh, a lot of you rounded off really early in some of this. Not a lot of you. Some of you round off really early in some of the quiz stuff. Again, don't round off in the middle of the process. Round off at the end of something. You got their game night? Huh? Game night? Okay. I saw you didn't have any home games this week, right? Saw that. All right. So again, that's more review stuff. Well, that second one was review. The first one, that's on your next quiz. So the math problem behind this is they would give you like some kind of an equation here, 3x plus 20. And then they give you an equation here, 6. Everybody saw that. I'm finally believing it. 6x subtract 30, something like that. So they give you two equations. I guess technically I should do this just so consistent. So they're about degrees. So what would our equation be? How? Saying what I just went over like 5 minutes. Yes, here, I can probably get rid of some of that. There. Our equation. X plus 20 plus 6x plus 30 plus 20 equal 20. So again, that's one you need to remember because it's a situation where if you just set them equal to each other, you'll be wrong. I'm going to spend less time on the ones where I feel like you'll just kind of guess the correct thing to do. Oh, actually, there was one more thing. I totally forgot this. Here, hold that thought. Let me make sure this doesn't go away. So let me save this real quick. Shoot. Let me say this too. Might have already said. Oh, should have. What else do we know in that problem, the first problem? Another theorem that was on your quiz, but I just want to remind you of this theorem. So we know about the right angles. That's what we didn't cover, but there was one that we did cover. Also, retake, definitely. But it's the one you also will probably guess correctly, so that's why I don't spend as much time on those. What else is true in that figure? Helen. Gonna call him Williams. Good. So if we have two lines that are tangent coming out of one point, an exterior point, it's going to be a point outside the circle, we said the lines are congruent. They have to be the same length. Like, there's no way I can draw two lines that are, I mean, like they're basically going at the same angle to the circle in order to be tangent. They have to. There's no way I could draw that without them being the same length. Because if I slid like one point, like if I slid this point a little bit down and tried to draw it, well then now point R would be closer to point T than to Q. So like there's no way to draw it without them being tangent. Plus, odds are if you see two equations, your go-to is a set of equal anyway, so you'll guess correctly. So I'm not as worried about that one as I am this one where you don't set them equal, you have to add them together to be 1/8. Make sure you remember the angle is part of that more so even than fun. All right, so now in your book pages, oh shoot, one more thing. So this has to do with that same concept we just went over. If I have, oh yeah, I can zoom in more. If I have figures that are inscribed or circumscribed, whichever way you want to look at it, just keep in mind that last theorem. If you have a figure, if it's a circle inscribed inside of another image, remember you got a whole bunch of tangent lines. So from this point right here, that is a tangent line because that's the definition of inscribed. it means basically you've created a bunch of tangent lines, because that's just the definition of inscribed. So if those are both tangent lines, they're congruent to each other. I have a point outside the circle, and I have two tangent lines. It just so happens that all of these tangent lines are going to connect. So again, there are two tangent lines, so those two green lines would be equal to each other. So I have another point outside the circle over here, those two tangent lines. And again, the blue is not congruent to the red, and red is not congruent to the green. It's not saying that. I mean, it could happen, but that you can't be guaranteed that. It's just saying that those two lines that are the same color are congruent because of the point outside the circle and then two tangent lines drawn to the circle. So I'm not going to do any problems with that because it's the same exact concept as having just one exterior point and just two tangent lines. It's just got four of them instead of just one. You got 1, 2, 3, 4 exterior points, and then you got two tangent lines from each point. I'm not worried about that. So I think that was all to wrap up that chapter. All right, so this is luckily a relatively quick chapter. You hopefully will have a little time left to practice. Doesn't mean it's easy. Again, this is all brand new stuff. And it's a little tougher, it's a little tougher to conceptually understand this, so that means there might be more memorization. I'm not going to spend a bunch of time on construction. You're going to see, I guarantee you're going to see this on the EOC. For whatever reason, they like constructions. I think. I mean, I don't see it, but that's what I always hear. If you see a circle somehow being divided into parts, you're creating some kind of an inscribed figure in that circle. So if they split it into three equal parts, and they're skipping like it's every two. So they made 1, 2, 3, 4, 5, 6 tick marks. But they didn't connect they didn't draw a line from every single mark. Like they didn't go from there to there to there to there to there. They skipped every two. Well, that means every arc is the length of two segments, right? I kind of had one segment, two segments, one segment, two, 1 and 2. So if every arc is the same length, every chord is the same length. So that's a little bit of a review. If I know this black arc is the same length as the red arc, and that's the same length as the blue arc, and I just know that because they've split it into equal sections, so 2, 2, and 2. Well, the first thing we learned about chords and arcs is if the arcs are congruent, the chords are congruent. If the chords are congruent, the arcs are congruent. So that means all of these lines have to be congruent, so it's an equilateral triangle. Square is a little different. They just basically, and they don't, it's not as easy as they say to just draw a diameter in, so I don't think that's not, you can't really just do that construction unless you're skipping a piece of it. But if you draw in two diameters and you connected all four of those points, you would make a square. Again, same concept. Every arc would match. This arc would be the same as this arc, which would be the same as that arc, which would be the same as that arc, which means when you connect the chords, every chord would be the same length. Well, if all four chords are the same length, then you have a square. I'm not doing a whole lot with that. Just showing you because I know that's gonna. Oh shoot! Let me do one thing really quickly. How did I do this? Here. Apparently I can't save that setting, so I have to redo it every time. All right, so page 239. So still, as you can see, we have some tangents involved. We hopefully know what a tangent is now. We are learning a new term, though, this term secant. Not really any frame of reference we have from anything else we've done. So one, you got to learn a new vocabulary term. So they give it to you right here. So a secant It's not a chord because the chord has endpoints on the circle. It's similar to a chord in that it goes through the circle, like a chord goes through the circle. It's just that it's a line that keeps going. So this section of that line and this section of the line, those are chords. So they have like the line has chords in it, sort of, but it'll have some of the same properties, but it'll have some different properties. So that's what a secant is. I don't want to tell you to use the word chord in it, but just understand when we get to some of the properties, they might be similar. And then tangent is still tangent. So. All right, so here's our theorems. Yeah, just these. There's some there. I think there are some more later. So if secants and chords intersect on the interior of a circle, then the measure of each angle formed is 1/2 the sum of the arcs intercepted by the angle and its vertical angle. So told you it was going to get a little bit more complex. Now we're getting, and you're going to have a bunch of these that you're really just going to have to memorize. What was it, 239? So let's talk about that one first. So if two secants or chord, because again, I told you secants and chords were going to have some of the same properties. So they intersect inside the circle. So you'll see down here, they're intersecting inside the circle, right? I've got a chord here. I got a chord there. They are intersecting. Could look all kinds of ways. Could look like this. They both intersect there. Could look like this. Lines going through. Barely inside the circle, but they intersect inside the circle. So any of these, I mean, what else do we know about this one, by the way? Something else that we learned about this one. Get rid of that and we'll come back to it. We learned something about that you should pick up on. You again, do a retake. Notes. They gave us some information for a reason. Tells us something else. Say it again. Well, there's no angle K because there's a whole bunch of K angles where K is a point. So if you say angle K, that doesn't. Yeah, you got to use 3 letters to name angles when you got that many angles coming out of one point. So that would be true. They're vertical angles, so you do have vertical angles there. But there's something else. Well, put it this way: you should know angle X without any math. Yeah, it is a perpendicular bisector. That's what this tells us. If we know that chord got split in half, we know there has to be a 90-degree angle. And what's true about MP? Only way that we can split something in half is it bisect, but what does it, in order to bisect? Well, you're just telling me what bisect. Well, no, I know it's bisect. We already covered that. But what does that mean MP has to be? Just remember, I can draw all kind of. So I could draw all kind of 90-degree angles, right? I could draw a 90-degree angle over there. That's a 90-degree angle. Did I bisect it? No, I didn't even come close to bisecting it, right? This half, or not half, this section is way longer than that section, but I have a 90-degree angle. So it's not all 90-degree angles bisect. It's the fact that if I move that line right in the middle of the circle, so if I make it a diameter, that's when it bisects. So it has to be a diameter to bisect, and if it bisects, it has to be perpendicular. So that would have to be known. But both of those things have to be true, we said when we did that before. Well, any 2 things we said had to be true. Because clearly that doesn't bisect, but yet it was a 90. All right, so that's just a quick reminder. That was that your last quiz or your two ago? I don't even remember. I think it was your last quiz. No, I'm sorry, it was two quizzes ago. It was right at the end of the one we did two quizzes. Okay. All right. All right, so now let's go back to that first theorem. So it says if two secants or chords, it could be one secant, one chord, two secants, two chords, could be any combination of those, just two of them, intersect inside the circle. So I would suggest you write your own notes around that theorem because there's no way you go back and understand. Well, I shouldn't say no way. It will be challenging to go back and figure that out on your own if you don't have some notes around you. So the measure of each angle formed is 1/2 the sum of the measures of the arcs intersected by the angle. A lot of stuff going on. So here's why they gave you this. Those for x, we're talking just about x, which means technically there's another angle that has the same measure. So you can look in your book or if you can see that. So angle x ends in arc MN, which is 117. Well, it kind of also, because again, these are vertical angles. That's really x also. Vertical angles is something you got to remember. Even though that was a long time ago, you'll see that, I'm sure, on the UC. So we kind of say angle x also, or at least the measure, whatever that measure is, intersects in QP. So what they're saying is the measure of these angles, any one individual angle, is half the sum of those two numbers. So if you, and we already know it's 90 because of the other theorem, so we better get 90. If I add 117 and 63, sure enough, I get 180. We said it's 1/2 of that. Again, here's your note. Trying to simplify it again. One that you might be better off memorizing. What is there a way we can? It's kind of the same. It's really sort of the same concept. I don't know. It's not. We don't have a rule because there's no inscribed angle. I'll see if I can come up with a good intuitive proof to try to help with the understanding of that. I did not use one last year. We just memorized it last year. There's no inscribed angle. There's no central angle. So those are really kind of our two intuitive things. So I don't know that there's going to be one. It certainly has something to do with the fact that if 117 is the measure of angle or the arc for angle x, well, the opposite arc would be make a circle. So I'm sure it has something to do with that, but I'll have to try to come up with it. So for now, you're just going to have to memorize it. So here's your note. If two lines cross inside of it, like you don't have to say secant, you don't have to say chord. If two lines cross inside the circle, the measure of one angle, so I would write the measure of one angle. And again, it's got to be the angle that corresponds with the arc. So the measure of this angle x wouldn't have anything to do with these out here. Like these arcs here don't correspond with x at all. Like x corresponds with the one above it and below. Like you got to follow the angle out. So just hopefully you understand that piece. Like x would have nothing to do with the arcs that are to the side of it. So angle x hits the circle at MN. So that's the arc right here that is associated with it. Well, like we said, this is also x. It's the same measure because of vertical angles. Well, it hits this arc down here. So again, two lines cross inside the circle. The measure, I'm gonna change. the measure of the angle. So we'll say angle. I'm just going to write the measure of the angle. I'm not going to write it. So the measure of the angle equals arc 1 plus arc 2 divided by 2. Again, all of this needs to be written in your notes because you're going to get a lot of formulas similar to this on the upcoming. I think it's this lesson, but if not this lesson, the next lesson, which will still be on the quiz. There's a formula very similar to this. So again, if two lines, I'm not worried. I don't think you'll ever need to know the difference between secant and chord for this type of thing. So if two lines cross inside the circle, the measure of the angle is equal to, and again, it would have to be the angle that corresponds to those arcs that we're talking about, is equal to arc 1 plus arc 2 divided by 2. And we already figured that one out, but hopefully this check problem. Oh yeah, there is. So do the check problem. It's the top of 240. I'm going to do I'm recording that. Well, huh? Girl, you look like you're squinting pretty good and did not have any glasses. There. How about that? Now it's not overlapping. There.
Oh.
Oh, plus. That's a plus. I'm sorry. Hey, look who it is. Well, you never start this lesson. Normally, if you this way, you just don't make it in.
Oh.
Well, actually, I don't know that for sure. Maybe you show up in the class. You're never late to this class. So we're moving into page 240 on your pages. So this is being recorded, so I'll post it hopefully at lunch. I'll let you guys work on that. I'm going to do attendance really quickly. It shouldn't take long, a couple minutes. Isaiah, how? Wake up. Like I said, I don't think retakes are going to be enough on this. Paying attention initially. Yes, sir. You got the answer. That seemed like it. Oh, yeah, I will do that. Let me finish doing this. Holy shit. Israel, wake up. Alvin. Yeah. Um, 2021. Perfect. All right, so I'm going to go ahead. Like I said, if you memorize this, it's not that bad. Problem is, if you don't do a good job of memorizing, if you don't know it like backwards and forwards, when you all of a sudden get a quiz with like 4 different concepts and 4 different formulas, and you're like, oh, wait, which formula was that? Then you're going to be in trouble. So if that's and again, I don't know of another way to teach this other than memorizing it at this point. I'll try to see if I can find something. I'm going to let you look in your book for that. I'm not going to try to redraw it or anything. We have two lines crossing in the middle, though. So that's your first hint. I mean, and again, there are past lessons with two lines crossing also. So you got to keep all those past lessons straight. But in this particular case, it says the measure of the angle. So angle X is right there. Measure of angle X is equal to the two arcs that correspond. So again, you follow the angle out, and the arc is LK on that side. You follow the other side out, and the arc is HJ. It will not be as easy as this, where they gave you two numbers exactly where you needed them. It will be much more difficult on my quiz and the EOC. So you say arc 1 plus arc 2 divided by 2. What would that be? 163 divided by 2, 81 and a half. 81.5, 81 and a half. So the measure of X, 81 and a half degrees. So just make sure you memorize that one, and it's not too bad. And when I'm saying memorize it, you got to memorize that along with the other 4 or 5 that we've already done or will do today and Thursday. So now we got to go to the next theorem. All right, so next theorem, if a secant and a tangent intersect at a point of tangency, interesting. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So I'm assuming that's this one. So does anybody have any idea, like, girl, I hope you don't have a phone out. Please, do. Don't, no. Put it up. Let's put it up. Put it up. Don't say it. I see it in your lap. Not to mention, I just saw you on. So I do not want to see phones. Again, I'm dead serious about that. I don't want to see earbuds. I don't want to see phones. Those grades were horrible on the last school. Horrible. And the exit ticket. The exit ticket, like I said, was the one that really pushed me over. It was the exact same problem I saw. And less than half of you got it. So I'll just tell you. This is kind of similar to the one we already learned. What did we say the measure of an inscribed angle is relative to its arc? Like when we just had a normal looking angle inside a circle. We said it was half the arc, right? It's the same thing. They're saying the same thing. It's just that the intercepted arc looks really different. So like if you go back up, it kind of says the exact same thing. It's just a different picture. So if a secant and a tangent, so now we're dealing with a tangent instead of just like an angle inside the circle, if they intersect at that point, so on the circle, at the point of tangency, then the angle is 1/2 the measure of its arc. So that's kind of that same thing. So this one's not too bad to remember. It looks very different, so it's not going to look like, you'll see, I'll go back down. It doesn't look anything like that. Not at all. But it is an angle with a vertex on the circle. So that part's the same. Here's my angle. The vertex is on the circle. Here's my angle. The vertex is on the circle. So again, there might be other ones that we run into that don't follow that pattern. I don't know if we do though. But that's certainly a pretty good hint or reminder of what the math might be. It's the same math that we do over here. It's a little trickier to find the arc. Where is the information on the arc? Oh, okay, there it is right here. It's not in the picture, it's right there. So if we know that the measure of FD, so it would be the opposite. If we know the angle, what would we do to find the arc? Again, that's the opposite math. So if the angle is half the arc is twice the angle. Just remember that. We did that before. That's nothing new. So if they're telling us F to D to C, and again, C is outside, but that doesn't matter in this theorem. It doesn't matter that it doesn't look like this. The key is we have a tangent. So they don't tell you this, which if they don't tell you CD is tangent, which they really should, because again, that's the theorem. It's got to be a tangent line and a point of tangency. So I guess just because we're on this lesson, we assume it. But if they don't tell you that, really, we can't say this for sure. But I will tell you that. I'm hoping the EOC is consistent and will tell you that the line is tangent. It's clearly not a radius, right? So we don't have anything where we can say it's a 90-degree angle or any of that. So don't think there's a 90-degree angle there. That is not a radius. So it's only the tangent line is only perpendicular to the radius or the diameter. So I'd write that little note in saying not 90 degrees because that's not a radius. I'm talking about FD. That is not a radius. It's not a diameter. So we can't say it's 90 degrees. Looking at it doesn't even look like 90 degrees. The only thing we could say then is this angle is half of this arc. Or the arc is twice the edge. So if you haven't filled it in, I'll let you take a shot at it. Actually, while you're doing that, I'll just fill it in. That's the angle. So again, the angle was half the arc is twice the angle. Well, they told us what the angle is, so we just multiply it by 2 to get that arc. I don't know what their measure of J. Measure of J. L. J. What in the world? Oh, arc J. Okay, yeah, sorry. So again, this kind of goes back. I wasn't going to go over that one, but I will. So what's true about JK? Oh, she saw me looking at it, and I saw the fear in her eyes. And she looked at it. Is real. Again, this is tricky. I kind of expect you to get it. But what's true? So in the example in black, that I circled in black, we got some information. They don't tell you this. I'll tell you HJ is a tangent. What can you tell me about JK? Say it again. Well, it's a line. We can't really bisect a line because the line goes on forever. So you see the arrows, but you're on the right track. What if you see the symbol down there, right? What's that mean? So we know it's perpendicular. You know this is tangent. What's the only way a line can be perpendicular to the tangent? Like one way that can happen. Actually, shoot, that's not true. I'm sorry, I'm wrong. We would have to know it's a bisector we don't. So actually, we can't focus. So never mind. I was thinking it was a bisector too, but if they don't tell us it's a bisector, if it's not bisecting a chord, this isn't true. I was gonna say it's a diameter, but we actually don't know. I could still be perpendicular and move that line left or right. Now, if they told us it was perpendicular at the point of tangency, then yeah, then it would have to be a diameter. But again, they don't even tell us it's tangent. I kind of assumed that. So I'll just tell you what I was saying again. If I know that is the point of tangency, the only way I can draw a perpendicular line to a tangent line at the point where they're tangent is if that's a diameter or a radius, remember? So that comes from that other thing we did a little while ago. That's the only way you can bisect something. It's the only way it can be at the point of tangency. That's going to be a big one from actually to the end of EOC. And it's one that I feel like you can get. Like some of these other formulas going to be tough to memorize all these formulas. So that was the second theorem, and I think we're on the last theorem. Yeah, so again, still two lines crossing. Secant chord, doesn't matter. Two secants, two chord. Well, two chords can't really intersect outside. Well, actually, this doesn't have anything to do with chord anyway. So secant and a tangent outside the circle. So again, this, yeah, I heard it. This secant and tangent intersected on the circle. Now we're changing that a little bit, and we're going to intersect outside the circle. And if you so they drew in, did they tell us that they're both tangent? Yeah, so they're telling us both lines, those lines are tangent. Again, they do not have to both be tangent. One could be through the circle. They could both be through the circle. That's what this is saying. Make sure you make that note. So it could be two lines. So I would write could be two lines through the circle. That's what this first part means. Could be one line through the circle, one line tangent. Again, the key is they're meeting outside the circle, or it could be two lines that are tangent to the circle. Could be any of those three situations. Really, you could almost just write any two lines that meet outside the circle. Because a chord can't meet outside the circle, so it can't be a chord. So you could almost just say any two lines that intersect outside a circle. They could be tangent, go through the circle, doesn't matter. I think that's pretty safe. It's not 100% true, but it's 99% true. So again, in this case, I do have two lines that are tangent. That's tangent and that's tangent there. So, and I only know that because it says over here that they're tangent. So here's your next formula. Oh, I didn't even finish the theorem. So here's your other formula that is similar to the last one we did. It says the measure of the angle is half of the difference between the arcs. What's that mean? England, what's that mean? Half the difference. Instead of adding them together like we did in the last one and dividing by two, we're just going to subtract them. You just have to be careful. Make sure you find the bigger arc and then subtract the smaller arc. So going back down to here. I'm not going to zoom in. You got it in your book. The bigger arc is that arc. So QRS is the major arc if you go back to our definitions. Oh my goodness gracious. The minor arc, or basically the other arc, is that arc. So I would need to be able to figure out the major arc and subtract the minor arc. Here's the problem, though. I don't have any measures of arcs. I don't tell me anything about the arcs. So somehow, so this brings two concepts in, which again is why circles get difficult. It's never just one, well, sometimes it is. I somehow have to use this 36 degrees to figure out the two arcs. How are we going to solve it? I mean, I know how to solve it. I'm just saying, how am I going to try to teach it? I say we just got to do it. So what's true about the green plus the whatever color that is, pink, purple, whatever you want to call it, fuchsia? The circle, right? So I know I got a circle, right? I don't know what either arc is, right? So what does that mean I could do if I don't know what something is? What do I label? variable, right? That's why we have variables. We don't know something. So I'm gonna label the green arc X degrees. But what's the problem? What do you want to label the purple arc? Well, pink, purple, whatever that is color. That's the problem. What if we make it Y? I don't know if you heard. I don't know if I heard. So Mila said, does it have to be? I think does it have to be another variable? Well, we can. It's an unknown, right? But we can make it another variable. I can say it's Y. So the pink arc is Y degrees. And then I could say, according to my formula, so it's my new formula, Y subtract X, it's the bigger arc, subtract the smaller arc, divided by 2 is the measure of the angle. That's a correct formula. We labeled one unknown X, one unknown Y. I know if I divide that difference by 2, I get the angle 36. We are 100% correct with that formula. What's the problem with that formula? Not whether it's not a problem with it, but what's our problem if we try to use that formula? We can't solve if I have 2 variables. We can never solve one equation with 2 variables. We want to try to keep it down to 1 variable. Did you say you know how? Oh. So again, this is what makes it. Well, we can't. We don't know. There's nothing. The only formula we have is that formula. We don't have a way to just say, well, I know this part of the arc is something. Green back. Well, we could, but then we still would get, if I multiply by 2 to get rid of the 2, I still have Y subtract X equals 72. I still have 2 variables. I didn't get rid of any variables. We need it down to 1 variable. What? No, we don't know that. There's no theorem that tells us 5. And plus Y is bigger than half the circle, so there's no way. What's true about a circle? Oh, boy, let's think about that. We know a circle is 360, right? So if we know this is X, what's true about the other side? Like, let me give you a hint. If I told you X was 160, what's the other side? Hmm? Say louder. So if I told you what X was, didn't you just solve for the other side? So what'd you do? Sandy, what did we do to solve for the other arc? If I told you what X was. Yeah, I know this whole circle has to be 360. If I know this part, I know that has to be 360, subtract that number. So I don't need a number to write that formula. That's how you keep it to 1. We've done that before, like when we did length. I said, if I know a whole line is 17, I know that's X, right? Well, then I know this section is 17, subtract X. So we've done that, something similar to that before. I know the whole line is 17. If I tell you I don't know this, well, then the other section is 17, subtract the X. So again, it's nothing super, super new, but not always something that pops into your head. Just make sure you understand. Here's the moral of this story. Make sure you understand you need to have 1 variable. If you create it using 2 variables at first, that's fine. If you set this up, you get some partial credit for that, but just you can't solve that. You got to then think, okay, is there any way I can figure out another way to represent this Y that was Y? And I represent that with only 1 variable. And that's what we would do. We'd say, okay, well, if I know the whole is 360, if I subtracted that, that would give me the others. So again, once you see it, it's kind of like, oh yeah, that makes sense. But the question is, would you come up with that on your own? And the only way you're going to be able to do that is if you do a lot of practice problems. So they've solved it for you, but why don't you? I'm assuming there's probably a check problem question. I'll think about that for a second while I'm thinking about it. Let me see where we're at.
I guess I'm interpreting.
Yes, let me think about that too. I'm trying to figure out how much more I'm gonna have. Oh yeah, we got quite a bit. Go quickly because we got quite a bit left. We got to still get into some links and stuff that I don't know in here. Forgot we had links and stuff. And then I'll get you something to. Oh my goodness. Did you have a question too? Sorry. Oh boy, I don't love this. So again, dry erase, if that keeps you engaged, I'm all for it. Problem is, you then go back and you don't have it in your notebook and you can have no idea how to do some of these problems. So again, I'm not super wild about everybody jumping on this dry erase marker bandwagon. Because you're gonna have no idea when you try to do these on your own how to do them. And you have to practice outside of the class. There's no way you're gonna get this practice. Oh, that's why I just got that. So it's got. All right, so again, that was all angles. We had degree symbols. We learned two formulas about the measure of angles relative to the measure of arcs. Basically, when two lines cross. Now we got another one coming up. Bunch of theorems that are about lengths. So now look at 241. So we're still doing tangent secants, but now we're going to learn something about the lengths of the lines. Let's see if there's any new definition. I mean, nothing super, nothing that's, I don't think, gonna be super weird. So again, if two chords intersect, actually, it's got it down here if you'll notice. So that's all you really need right there if you understand what that's saying. It's color coordinated. When two chords intersect, the segments are just called chord segments. So that is a chord segment. That's a chord segment. That's a chord segment. That's a chord segment. Now, this is not one that I really can come up with a great intuitive way for you to just recall enough information to figure this out. This is probably one you're going to have to memorize, which means you've got to practice the night before. Quiz will be on Monday. Oh, shoot, I don't even know what your exit ticket will be yet. I'll have to look at the practice problems and we'll figure it out. If you have two chords that intersect, so again, we just dealt with lines intersecting. Now we're dealing with lines intersecting again, but it's about the length of the segments, not about angle. There won't be any degree symbols in any of this stuff. So that's your first hint. Write that down. No degree symbols. So your problems will not have degree symbols, but it'll still have lines intersecting. Could be inside or outside the circle, I think. Yeah, it's really not. Those other ones really aren't about intersecting. So this one may be kind of its own separate pyramid, so that makes it not too bad. So two lines intersect inside the circle. It's kind of a proportion thing, I guess you could say. If I take the product of those two segments, it will equal the product of those two segments. So this is what you're looking at on the left that I had circled a second. It just means you multiply the two together. You multiply the two. So for the same chord, if you multiply the two segments together, so I multiply, actually here, let's do this. I'm going to multiply the blue times the blue. That will equal the red times the red, whatever they are. So that's what this is saying right here. That is saying if we multiply the red times the red, it will equal the blue times the blue. I don't think they're going to give you super tough algebra because theoretically, if they give you a bunch of variables, you could get into like squared terms. If there's an x and an x plus something, you multiply them, you have x squared. I don't know how tough the EOC is going to get. If they're going to. Actually, this one isn't the one that lasted forever. I think I still have the one that's lasted forever. Yeah, still lasting. Look at that. See, that's what I'm talking about. How does that rip and it's been there a week? This one's lasted for like a month. So if I'll try to come up with some intuitive ways to help on Thursday for those, but right now you got to memorize that one and you got to remember those two formulas we did about angle. That's three things you're just purely memorizing from this lesson so far. So far, we got more here to memorize. So the next theorem, and we'll get into problems in a second. I'm just going to do all the theorems. The next theorem. So again, we have two secants. What is a secant, Isaiah? What's a secant, Isaiah? Let me see yours. I need to do it. Isaiah, let me see your ears. Hear me? That's what you listen. What is a secant? You don't know, just say don't know. Then move on. All right. What is a secant? Pull this up. Yeah. So remember, a secant is like a chord that just keeps going. It goes through a line that goes through the circle. That's all a secant. It's not anything. I know it's a weird word. You've never done it. It's not anything super great. It's a line that goes through a circle. These are secants down here. So that's a secant. That's a secant. Goes through the circle. These are chords because they stay inside the circle. They have endpoints on the circle. So those are chords. They have a lot of the same properties. Well, they don't have to touch outside. I mean, I guess if they were parallel, they wouldn't touch. They just go through the circle. So like if I have a circle, I draw a line through it. That's a secant. Now I could draw another one that's parallel and then they'll never touch, but it's still a secant. Or I could draw a third one that's not parallel and touches both of them. Again, it's just a line that goes through the circle and it goes all the way through.
What was the difference?
This stops. Endpoints are on, so it doesn't go all the way through. So no, it has nothing to do with the middle. Do these lines go outside the circle?
Oh.
So a secant has a chord. Like this part of that secant is a chord. That segment is called the chord. The whole thing is a secant. So that's why they have some of the same properties, is because a chord is kind of part of the secant. Yeah.
I was going to ask.
Yeah, they're going to have something like, if you notice, when we did, I think it was the very first theorem, it said a secant or a chord, right? Yeah. So they're going to have a lot of the same properties because, like I said, a chord is just part of a secant. So it's going to perform the same way that the secant would, or vice versa. So yeah, absolute. Now, it could be different.
Does it have to go outside the circle on
Yeah.
both ends?
Oh no,
No.
because this one doesn't right here.
Okay.
So, all right, here, let me just get rid of it. So yeah, this one here is outside the circle. It just, again, the difference is chords both endpoints are on the circle. A secant, they're not. So it could be one endpoint still on the circle or none. So here's our next theorem. So if two secants intersect in the exterior of the circle, so the two secants intersect there. Now we did something sort of like this when we did tangents. Remember, we drew in two tangents from something outside of the circle. That was more about angles. Now we're dealing with measures of lines. So let's see, then the product of the measures of one secant is the external segment. Blah, blah, blah. That is so confusing. So we're just gonna look at the color coding and look at the formula down below. So look at what they've drawn for you. Can I zoom? I'm gonna zoom in more on this. So hold that thought. I mean, you can read it in your books while I'm zooming in. But yeah, there. That's the problem with zooming in. For some reason, it jumps around. I don't know why. Oh, it's really there. Oh, wait, no, that's not it. Next one. Yeah, there. All right, so they've color coordinated it for you. So again, this is a similar formula, the one we just did. When two chords intersect, we said the product of the two segments equals the product of the other two segments from the other chord. It's the same concept here. So the product of, what is it, AE. Oh, it's a little different. I'm going to color coordinate this. AE. So AE is the blue line. Oh, am I going to show you another? Oh, actually, we'll do it this way. We'll change. So I'll do, instead of same color, we'll do different colors. So the blue, so that whole blue line times the red is what they're saying on this side. So again, we're still dealing with the same segments of one secant or one line. You can just think of it as a line. Just like up here, it was multiplying the same segment. I'd write that note. I don't know if the third one changes, but so far, we're always multiplying numbers from the same line. Up there, it was the same numbers from the same chord. I'm sorry, numbers from the same chord. Now it's numbers from the same secant. But here's the difference. Well, actually, let's talk about the difference. Brianna, what's the difference? What am I doing differently? Here, I'll zoom out quickly for this. What am I doing differently? So here we multiplied these two together. Down here, we're multiplying the blue times the red. What's the big difference? This is what your note is going to be in a second. Well, how? Pay attention. What is the difference? What did I do up here? I'd look at what I've got in there. I'm going to have it. I multiplied this segment times this segment. Down here, I multiplied blue times red. What's the difference? I'll give you a hint if you don't see it. Well, we're only dealing with one chord right now. I'm just trying to give you guys a note to write so you can help keep some of this straight. So you got a lot of memory. So this is about chords. I will write that because that's going to be one of your kind of your triggers. So when we're doing lengths of chords, we're going to do it one way, and then when we do secants or lines outside the circle, we're going to do it another way. What is the entire chord up in the top problem where I've got all red? What's the name the chord? Give me 2 letters that name the chord. Is that the whole chord? A C. So the chord has endpoints on the circle, right? Did we use a C up there? We did it, right? We are multiplying the 2 smaller segments. So that's 2 and that's 3. We're multiplying the 2 times the 3. What are we doing down in the bottom one, or not bottom, but the next one? Are we using the segments? Zoe, we're using the segments in the next one. Are we? What's true about the blue line? Is that just a segment? Oh, down here. It's not, right? So here's your difference. When we go to secants and we have a point outside, we're going to multiply the entire secant times so the entire secant times this little section that's outside the circle. That's what this formula is telling you. AE times BE. So the entire segment times the little segment outside. Here we use both segments. We didn't use the entire segment at all. So only use segments is what I'm going to write here. You got to, if you don't know what I mean by segments, then use some other words. It's the little pieces of the little sections, whatever. I mean, segments is the correct name. That's what we learned when we did line segments. Here, when we're doing secants, let me see what the next one is to make sure I. All right, so we'll say two secants. So here, when we do two secants, well, I'll write it, coordinate it. So when we do two secants, and again, this is all about lengths of the segments. Still trying to find lengths of segments. So when we have two secants, we use a whole secant times the out. I guess I'll say outside. That's fine. Outside segment. Again, that's what that formula is doing. And you do that with both lines, or both secants, and you set them equal, just like we would do this with both chords. This is not going to make sense, but so again, 2 times 3 would equal 6 times 1. We take the individual sections of one chord and multiply them and set that equal to the individual sections of the other chord and multiply them. Down here, we take the entire secant and multiply it times just that little section outside. And then we set that equal to the entire secant times just the little section outside. And then and one of them will be a variable, so you'll just have to then solve for the variable. And then the last one, oh boy, we slowed down. We got to if a tangent and a secant. So now we have one secant, one tangent. And tangent would mean we're only touching at one point. You would have to know if there's a diameter or a radius, it's at a 90-degree intersection. We would take the tangent line. So again, I'm just kind of going straight to the formula. It's easier, I think, than doing all the words. We take the tangent segment really. So from the point of tangency to the point outside the circle. So if that tangent line kept going, you would have to know you're only using that section. Like if the tangent line kept going all the way across, you'd have to know you're only going from the point of tangency to the point outside the circle. And we're going to square that. That's what this is. So if this is a 2, part of our equation would be 2 squared. And then we're going to come to the secant line, and they are just multiplying. Again, it's the whole secant times the segment outside the circle. Here, let's write that. So tangent line, tangent, I'm going to say tangent segment. Hold on. Tangent segment squared. So that 2 means squared. So you take the tangent. Oh, so this is one tangent, one secant. So I'm just trying to simplify all of this stuff here. So when you have one tangent, one secant, you're going to take the tangent segment and you're going to square that number. It'll only be one number. There's not sections of the tangent. So square that. That will equal. So I'm gonna just write over the top of stuff. The whole secant. Yeah, whole secant. So you take the whole secant. Ugh. Oh. I didn't work at all. So it's the whole secant times, and again, the section outside the circle, the segment outside the circle. So that's what that formula down there is saying. The whole secant, and you set them equal so that hopefully you see the equals. So again, take the tangent and square it times the whole secant, or I'm sorry, tangent squared equals the whole secant times the section outside, the segment outside. Again, no intuitive way to come up with that one. So you got a lot more stuff in this chapter that you, or lesson, that you just have to memorize. That's 4 formulas at least, more than that, really. I'd say you're probably going to be memorizing 5 or 6 formulas from this lesson alone. So if you're relying on memorizing the other ones from other lessons, actually, you do have one thing from the last lesson that's on the next quiz. Boy, that took way longer than I thought it was going to take. We had a bunch of time. I thought we were going to have some left over. Any questions on any of that? So I believe these are just practice problems. I don't think we have any other lesson stuff. Yeah, so you can try to solve. We did that one. And then we started over there. So yeah, so you can try example 4 and example 5. I'll probably in 3 minutes at least get you set up. I'll write up the problems you're responsible for as well from the practice problems while you guys are working on example 4, example 5, example 6. My guess is that's going to match up with, well, yeah, it does. I can tell you that right now. So this matches up with the first theorem on chords, on this length of chords. So you'll see that's 2 chords. So it matches up with that first theorem on chords. Here we have 2 secants, so it matches up with a formula about 2 secants. Here we have a tangent and a secant. So they match up in order. Just follow those formulas we just did. You're going to have to memorize those formulas. And let's see. So what can we do for the exit ticket? This will be your exit ticket area right here. Page 243. So 1 through 6 is exit ticket material. Sure. I think I'm just going to pull it from that section. Well, this is 243. So I don't know what the examples would be the page before that. So 242, like, what was it, 4, 5, and 6, I think. But yeah, that. Keep that in mind. I'll just tell you right now, I'm not going to take it that easy. There's going to be more to it than that. I'll tell you how I'll do it, but you need to understand, you need to find the arcs associated with the angles, add them together, and divide by 2 to get the angles. But I'm not just going to give you the 2 arcs right where you need them, and then have you just add those 2 numbers and divide by 2. There's going to be a little more to it. So make sure you understand that, not just plug in numbers. So now we'll do 7, I guess the rest, 7 through 16 on that page. 7 through 16.
Let's go ahead and say what I said.
1 through 6. I go move that. I think I got to shrink this down as well. There. So let's see. What's the next section? Yes, certainly 17 through 22. And through, so it looks like 17 through 26 on 244. No. Two 44. 17 through 26. And let's see if there's anything after that. Really want to challenge yourself. I'll assign 28 through 30 on 245. So that's all your problems for Monday. Hopefully we get a little time class Thursday. I really expect you to have some time today, but really slowed down apparently at the end. Oh. Probably more than that. I think we did more than that. Because you add both arcs together, divide by 2, track 2 arcs and divide by 2. And then I think there was a separate one for each of the other 3, so that's 5 already. Don't think there were any other ones. So, yeah, at least 5. And then we actually did one problem from the last lesson. Did it have a formula? And it sort of had a formula. Really, that one was more of a concept where the 2 angles just had to add up to 180.
Guys, that you've got like 4 or 5.
And I'm sure the next chapter has a bunch too, so don't wait. Definitely do not show up Monday and you didn't look at it at all over the weekend. Because then you're stuck on your own trying to learn it or going tutoring and trying to learn it. That's a lot to learn in one tutoring session. Wolverine?
Yeah.
That's a new school Wolverine, not my old school Wolverine. Don't forget, deadline Friday. You owe me tutoring. You got to get that done. Somebody tried to show up without tutoring last Friday, and I said, no, sir.
Didn't show us.
Oh, yeah. What did you want to say? I'm sure you. Yeah, I thought we were going to have time, but that last section was way longer. I mean, I'm sure I could have gone faster, but I'll have my planning, my long planning tomorrow. So I'm gonna, well, Let's see, second period.